Okay, look around. Good. What kind of tourniquets do you use? What county are you working for?
I work at San Bernardino.
San Bernardino? You teach. Okay, good. So, do you have the good tourniquets that we have, or the crappy tourniquets that Riverside County gives? Yeah. Okay. What kind of tourniquets do you got?
I don't really use them. I work at the hospital.
Oh, okay. Never mind. All right. Yeah. Okay, because I just got a box of them, so I thought I'd bring in. Yeah. So, okay. Rossi. Good. Vivian. Good. Tyler. Tyler's here. Good. Michaela. Good. Okay. Nancy. Okay. Talia. Awesome. Arthur. Right on. Brenda. Yes. Good. Tamiko. I'm gonna mispronounce it again. Is it Tali? Yeah. I'm gonna have to sit and practice. Okay. Anna. Josh. Okay, good. Joanna. Good. Manuel. Right on. Annabelle. Okay, if you're not sitting by your study buddy, get by your study buddy, because we did an activity starting at first thing this morning. Okay, we're going to talk about the results. Maritza. Maritza Rivera. Okay, good. Melissa is here. Alexandra. Good. Melissa Torres. Yeah. Okay, Grace is here. Good. Julissa. No Julissa? Going once, going twice. Okay. Haley. No Haley. Victoria. Awesome. Sydney. Okay. Ebony. No Ebony. Madeline. Okay. Chloe. Good. Michelle Dane. Right on. Sierra. All right. Alea. Catherine. Jada. Good. Jesse. Victor Lopez. Right on. Soleil. Good. Alyssa Martinez. Anaya Patel. Good. Justice. There you are. Okay. Raul Rodriguez. Raul? No Raul. Okay. James. Right on. Ivan is here. I saw him. Okay. Paulette. Anna. Good. Mina Hall. All right. Last group. Fabian. Veronica. Good. Eliana. 20. Ooh. Okay. Eliza. Emily. All right. Leonard. Okay. Janet. Okay, good. Kimberly. Right? Jimena. Okay. Rafael. Good. Tatiana Lopez is right here. Caitlin. Absent. Okay. Gabriella. Good. Eric. Right on. Samantha. Jetta. Good. Jacob. Good. Zadali. Okay. Desiree. Good. Mustafa. All right. Y'all moved. You were up here, now you're moved. Yeah, okay. Okay, right on. Okay. Kate. Okay. Maritza, Vera, okay. Kiana, and Janet. Okay, good. All right, let's see what you had to say about the scientists we talked about last time. There's a whole boatload of them, okay? How many did you count? You should have 10, all right? You should have 10 that we talked about. Okay, all right. Well, who was the most important one, do you think, for the impact in microbiology? Who do you think was most important? Raise your hand and if you Aristotle. Yeah, he started a lot of things. Okay, yeah. Van Leeuwenhoek, okay. Yeah. Ready. How come ready? Okay, disprove it was biogenesis. Go ahead. Jenner. Okay, why did you say Jenner? The vaccines, yeah. Vaccines, yeah. Oh, Fleming and penicillin. That's good. How many said that one? Okay. What else? Who else? Yeah. Pasteur. Okay. Why? Cheese and wine. Can you say more? How many said Pasteur was the most important? Okay. Yeah.
Lister because you make the antiseptic.
Okay, Lister for antisepsis. How many said Lister was the most important? Okay, most days I think that one really seriously. I don't know, Aristotle.
Calm down now.
Anybody else get Aristotle? I'm just curious.
I thought about it.
You thought about it? Oh, you guys are awesome. All right. So, did it help to kind of jog your memory? Okay, yeah. That's why I try and get here as close to everybody trying to get here as close to 9:25. Get a seat, and then you can start your brain working, so you're not coming in cold. Okay. So that's cool. So I've been going through some of your answer sheets, like to get to know you. Wow. That's all I can say is wow. You guys have great history. Done great things. It's awesome. So yeah, it's an honor to be a professor. So yeah. So as you know, we didn't have a quiz today because I'm lost in time. And thought that this week was week 3 for some reason. I don't know why. I'm counting down to spring break. I don't know what's going on. So let's do a few things to try and understand. Well, actually, we do need your lights on because you want to see your cards. So let me see if I can get, there we go. Let's see if we can get a couple things here. Okay, so how many of you worked hard to get your cards in the last 48 hours? Did you get them? You tried? Okay, good. All right. Do you have card number 1 out for Triple S? You got your Triple S card? Get your Triple S card out. You've got it, because we're going to go over some details. Okay. Can you still see the board? Yeah, and still see your cards? Yeah.
Do you prefer us to write or type the?
For the first batch, you can type them if because you can just print out that sheet, right? But you'll probably end up rewriting them at some point. Okay. The reason is as you learn more stuff, you add it to the card, and you're like, oh, I'll just redo it for more space. So I'll leave it up to you how you want to do it for next week's quiz. Okay. All right, off we go. So this is how to make a disease card, and we're going to start with Triple S. Sometimes it's called quadruple S. Scalded skin syndrome. Why do you think it's named that?
It looks like the skin got burned.
Okay, yeah, it looks like you've scalded your skin and it starts peeling, okay? Now, most of the pictures I have are from babies and infants because they tend to get it, okay? All right, so let's start off with your disease card, okay? These are all the categories that you really need to consider, okay? The disease name and the causal agent name, sometimes you just have a disease name, okay? The pathogen type and description, okay? The main body systems affected. For this one, this is easy. What's the body system affected? Skin, okay. All right, sometimes you have more than one body system, okay? And this is where the 50A part comes in handy because you know your systems very well. Okay, unique virulence factors like toxins, enzymes, latency. Okay, there are some diseases you're going to run into that have an incubation period of 20 years. Okay, that's a long time. Okay, reservoirs and disease transmission, portals of entry and exit, which is a lot of chapter 13. This is why we do chapter 13 early, so you can get used to the terminology. Okay, what do you need for diagnosis? What are this SNS? What does SNS stand for? Signs and symptoms, x-rays, etc. Okay, microscopic appearance and shape of the etiological agent, the staining, the isolation media, and biochemical tests. So for scalded skin syndrome, you're going to have a number of tests that you do. It'll be several weeks before you learn how to do those in lab. Because what are you doing this week? Gram stain, streaking. Okay, what else? You don't do acid fast anymore. That doesn't work so well. But gram stains and that. Our micro for acid fast doesn't work, and you have to flame it, and so it doesn't work so well. But what micro cause it that you need to test for acid fast? There's only really one, and that's tuberculosis. Okay, so microscopic appearance, staining, isolation, DNA tests, serological tests, prevention and treatment, complications, sequelae, chronic disease, latency, and then anything else that's useful. In this case, we're concerned about an age group for SSS because why? You usually only see it in infants, okay, and very small children, okay? And you also want to know multi-drug resistance. Okay, so where do you get information to do all of this? Start with your book. Go to the back index. Look up your microbe, okay? Write down the page number and the chapter on your card, so if you need to go back and read about it in 6 weeks, you don't have to go and re-look it up. You know it. It's right on your card. Does that make sense? Okay? All right. Read the chapter and the general information about whatever the causative agent is. Even if it's not on the syllabus right now to cover this week, make sure that you do that. Okay. Look at all the pictures and tables. Okay, pictures help. Okay, the thing about Talaro is question.
Would we be able to put pictures in like the corners of our boards?
Sure, if it helps you, go ahead. Yeah. Chapter checkpoints and just look at the checkpoints in the chapter summary for those chapters that are heavy in infection. And then, of course, on week 1, you printed out Table D, right, from Talaro from years ago. Okay? Talaro has changed. They no longer have a Table D. This is from 2014, and it's still the best out there. Okay? So we got permission to reproduce it for this class. Okay? All right, let's start with SSS. Disease name. What is it called? What is the casual name for it? Scalded skin syndrome, okay? The main characteristics of it, what is it? You look at a patient, how would you suspect scalded skin? What does it look like? Okay, it's redness, blisters. You're actually losing the dermal layer, okay? It's not just, oh, I got sunburn. I mean, you're having skin slough off. What's the causative agent? Staphylococcus aureus. And you're like, do I need to be able to spell that for the quiz? Yes. And you got to remember to capitalize things, okay? Bless you. All right. So remember, it's, okay, so here's a disease name, scalded skin syndrome or staphylococcal scalded skin syndrome, okay? Watch this. AL versus US. Very different. US Staphylococcus aureus is the scientific name. Don't confuse the two because it changes the meaning, okay? Is that cool? All right. Yeah, be very careful about that. Is that going to be something, if you put Staphylococcal aureus on the quiz, it would be wrong, okay? You'll get a mark wrong. Okay, so what is the type of etiological agent? Well, is it a bacterium, a fungus, protozoan, helminth, okay, prion infection, or intoxication? Okay, and for this case, what is it? What is the etiological agent? It's a bacterium, okay? Now you got to get a little more detailed, okay? What is it? Is it a cocci? Is it rods? Is it vibrios? Is it spirochetes? Is it mold? Okay, all of that good stuff, okay? For this one, is it gram positive or gram negative? This is a gram positive, and it's a cocci. So what shape is it going to be? Circles, and it comes in clusters, and this is what you look at under the microscope. It's very clumpy, okay? Now, the other thing that we're going to be doing this semester is a lot of metabolism tests, because some of these are microaerophiles, some are facultative anaerobes, some are complete anaerobes. Now, this happens to be a facultative anaerobe. Okay, what does that mean? What does the term facultative anaerobe mean? It can be anaerobic, it can go both ways, right? It's, okay, so yeah, it can have oxygen, but it can also live in anaerobic conditions to a certain extent. Okay, do you have this all on your cards? Okay, good, good, good. All right, now, we're going to talk about this in chapter 13, but be careful about intoxication. Okay, we're not talking about, you know, a 40. Okay, we're talking about toxins that are poisons. Okay, so you get intoxication are like microbes that produce some kind of toxin that causes the effects. What microbe does that you can think of as you've been reading? Tetanus is one. Yeah, tetanus is one. It's a toxin. Okay, what does it do? It's a neurotoxin. So it's funny. You'll understand this. We had to do weapons quals this weekend, right? I'm not good at it. We did the simulators first, right? So they take us in this giant warehouse and we get our simulators and we have to qualify on an M9. Okay, no big deal. So, enlisted go up, my medics, expert or marksman, they were awesome. Okay, they go up, they're able to do the trials, and then on their qualifiers, they do really well. The officers go last, and let me tell you, my officers need some help. Okay, they're not shooting very well. And so I have a nurse practitioner that is awesome. She's was deployed for COVID. She got hurt during COVID. Not sick, but hurt, because remember in COVID, some of the step-down patients were getting a neurological thing and freaking out. She got really seriously injured by a patient. And that was at one of the hotels, you know, because you don't have restraints at hotels, right? And we didn't know that this was a problem in the patients that were sort of sick, but not really sick. So anyway, we're in the last round of qualifying, and she says, "I feel something moist on my hand." I'm like, oh shit, man. So I said, okay, lights up, turn up the lights, and she had cut herself on her weapon. Really good. I'm like, how did you not feel this? And she's like, I'm focused. I'm like, yeah, no kidding. So she cut herself on a weapon. She's dripping blood, right? So medic, well, we're medics, so 16 whiskeys came, bandaged her up. And then we ask a question. What's the next question you ask? Come on, what's the next question you ask? When was your last tetanus shot, Captain? She's like, I don't know. I said, guess where you're going. Okay, why? Why is that your next question? It's metal, it's a deep cut, and tetanus doesn't mess around. It produces a toxin, and 6 hours later, she could be in real big trouble. Okay, all right? Are you gonna run into that? Sure you are. Yeah, you're gonna run into it, okay? So think about toxins. Have it in your mind that you wanna know what microbes produce toxins, okay? Then, by the way, she didn't qualify. Start bleeding in the middle, you don't qualify. So guess what we're doing next month? Anyway, okay, so, yeah. So please look at the difference between intoxication and infection, okay? So, okay, tissues and systems affected. We know this, it's in the name, skin, okay? Now, if you've really got a good eye, what else does this look like? I'm looking right here. What does it look like? If you have a little kid that got this, you know. What does it look like? Looks like impetigo. Okay? You seen impetigo before? It's kind of yellow and crusty and gooey. Doesn't that look a little bit like it? Okay? So, anyway, just a little. I mean, he's got a whole bunch of other things going on as well. I mean, he's lost skin here. But, you know, and where does impetigo tend to be? Right about here, okay? All right, skin and wounds. So, toxigenic versus toxemia. When you talk about a toxemia, this is where the toxins in the blood spread to epidermal layers, okay? So, lots of terminology. Toxic, toxigenic, toxemia, okay? So, make sure you know all of those. Signs and symptoms, S&S. What's the difference between the sign and a symptom? You know this. What's a sign? Something what? Something that the practitioner sees, right? That's a sign. What is a symptom? Something the patient reports, right? So S&S. Let's talk about S&S here. Okay? Painful, bright red, flush over the entire body. Why? Because the toxins are going in through the circulatory system, right? And going to the epidermis. Okay? Are these kids fussy? They're screaming. Okay? They're in pain. All right? Pyogenic. Pyogenic. This term means it makes pus. Do not confuse this term with pyrogenic. What is pyrogenic? Fever. Yeah, that's fever. So make sure you get the difference between those two. Okay? You get peeling. Okay? These are exfoliative toxins. What does exfoliate mean? Exfoliate means you're peeling off skin. Okay? So, yeah. Okay, what unique virulence factors do you have? Okay. Now, on your medical, how to do a disease card, there's a list of terms, and that's where this comes into, is a lot of terminology here. So when you talk about virulence factors, this is where the things that, what does virulence mean? We talk about that in chapter 13 today. What does virulence mean? Yes?
Something that enhances the ability for spread.
Okay, it's an ability to cause infection, right? That's what virulence is. Okay, and some of these microbes, okay, pathogen attachment, cell entry and exit, destruction of, this all leads to virulence. How sick can it be? And you know, the more virulence factors a microbe has, the sicker you're going to get. Okay. So what unique pathogen structures do you have? Do you have spikes or hooks or capsules or endospores or M protein? Okay. Toxins like hemolysins. Hemo stands for what? Blood. Lysin. What does lyse mean? To break. So if it's a hemolysin, what is it doing? Breaking the red blood cells. You're going to see this on a slide, okay? Enzymes of mass destruction. Okay, coagulase, hyaluronidase, staphylokinase, lipase. Okay, how do you know these are all enzymes? ACE, good. Oh, good. Anti-immune system chemicals like leukocidins. Okay, we see cidins, it usually means kill. What are they killing? White blood cells. Good, good. Drug-resistant enzymes like penicillinase. What do you think penicillinase degrades? Penicillin. Okay, have you had experience with this? You give something for a gram-positive infection like amoxicillin, and gee, it doesn't work, but Augmentin does. What's the difference between the two? Okay, we're going to learn this and then we do our chapter on chemotherapy, but Augmentin has a chemical in there that inhibits penicillinase. And so it makes it a little more effective. So you're getting some of those. See, these microbes are at war with you all the time. They're sending out chemicals. So they'll send out penicillinase to break down the penicillin. Well, if we can give the patient a chemical that will break down that enzyme that breaks down penicillin, we've got to edge up, okay? All right, good. Also, latency, like the herpes virus. Herpes is always there, right? Once you have herpes, it's always there. Where is it hanging out? What system does it hang out in? What is it? No? Herpes? No, because you can get herpes anywhere. Herpes 1 is above the belt. Herpes 2 is, simplex 2 is below. Where does it hang out? Nervous system, right? It's in the nervous system. So, yeah, and when you get run down, what happens? Comes back, right? So, I like to think I'm just like herpes. I'm always here. My family doesn't get that. Oh, Heather, you're so gross. Why do you say that? Because I can. Okay. I'm gonna have a drink for today. Okay. Exfoliative toxins, A and B. This is important for triple S. Okay? If you've had 50A, you've seen these slides before. You're looking at what? What are you looking at? Okay, you're looking at skin and you're seeing this big gap here that you shouldn't be seeing. Why is that? Because the toxins are causing the separation of the dermis. Okay, that's what you're seeing. That's why 58 before this class is so good, because you know what healthy tissue should look like. Okay, all right, so these are the toxins. Okay, destructive enzymes. We've got coagulase. Coagulase, what does that enzyme do? Coagulation is what? Clotting, okay? All right, and it does have drug resistance. It has a penicillinase, okay? Okay, how do we get this? This is where the disease reservoirs is where things hang out. Human mucous membranes, okay? And it's in the skin, nostrils, nasopharynx, oral cavity, and intestine, okay? It's usually normal flora. Staph aureus is found everywhere, okay? And it's environmentally resistant. So it can survive being dry, light, pH, temperature. There's no animal host, so this is a human reservoir, okay? When they admit you to the hospital, they do two things. What do? Those of you who are hospitalists, what do they do? As soon as you're admitted, what do? Okay, they do blood pressure and vitals and that. Boring. Okay, important but boring. Okay, they do two things. They should do what? I can't hear you. Real loud. A skin assessment. What kind of skin assessment? Okay, you're checking to see. Okay, so now they do 3 things. I didn't think about the skin. I thought about X-rays. Why? You do a chest X-ray. Why? You're going to try and track pneumonia. You want to make sure they don't have pneumonia when they're admitted, or because that's a nosocomial. Okay, what else do? They do a MRSA swab. Okay, what is MRSA? What does it stand for? Oh my goodness. Oh, ouch, ouch, ouch. Good guess. Good guess. Methicillin-resistant Staphylococcus aureus. Yeah. MRSA. If you don't know it, writing in your notes, that's one thing you've got to look at. What is MRSA? Do you have it on your card? Good. Yeah, it should be there. Methicillin-resistant Staphylococcus aureus. Okay. Where does it like to hide out? In your nose. So they'll do some swabs to make sure, because why? Some people are carrying MRSA and they don't know it. And it's so common in the community. Okay? So, yeah. That's cool. All right. Disease transmission. Okay. Triple S is nosocomial. Okay? It's usually in nurseries. Okay? Those poor little babies are so cute. They don't have an immune system yet. All right? You get it from close contact and poor hygiene. So what do you need to make sure that you do? Universal precautions. Okay? Now, it's from nasal, oral, right? This is the area it hangs out. Okay? It is also transmitted by a term we see in chapter 13, fomites. What is a fomite? This is a fomite. This is a fomite. It's a surface. It's something that's an adamant that can spread disease. That's a fomite. Okay? And you can get triple S if you've got a skin injury, like a cut. Okay. Are we ever going to be able to remove triple S from everything? No. Why? Because we're people. Okay? We're people, and we're not perfect, and we don't use perfect hygiene all the time. Okay, how does it get in? What's this? The umbilical stump. Okay, it gets in through the eyes and the skin. Okay, as you're doing your cards, the portal of entry is not always the portal of exit. Just be aware of that. Okay? All right. Now, the other thing to be aware of is that the tissues and the systems affected may be nowhere near where the portal of entry is. So we see this with osteomyelitis a lot, with bone infections. Okay? You get somebody that cut their hand or, is outside working, and then they get a bone infection. The portal of entry was where? Their hand. Where did the infection go? To the bone, and that's it. So it's like, wait a minute, I've got a bone infection? I didn't break anything. You don't have to. Yeah, you got a great circulatory system that will carry the microbes everywhere. Okay, let's talk about diagnosis. All right, we do signs and symptoms, isolation on media. We use 2 types of media. You haven't seen these in lab yet. I don't think so. I don't think they talked about it. Okay. You have blood agar and mannitol. Why would we look at blood agar? Okay. What this does hemolysis. What does hemolysis mean? It's blood cells that rupture. And so when you put it on blood agar, what you can see is, it changes the blood agar. So you're gonna see that. And then we do mannitol salt agar, okay? And here's what it looks like under. Remember, they make clumps, okay? It's gram-positive with irregular clusters. We also do, when we're trying to figure out if it's a strep or a staph, streptococcus or staphylococcus, we look at coagulase, okay? catalase. Catalase, if you were in Bio 1, you did a catalase test. What did you do? You took a potato, you put some hydrogen peroxide on it, and it bubbled up, and that was catalase, right? Okay. If you put hydrogen peroxide on a wound, what's it going to do? It's going to bubble up. What are you looking at? You're looking at enzyme. The enzyme catalase is making oxygen. Okay. So there are streps that are negative for catalase, and this one is positive for catalase and coagulase. What is coagulase? Coagulation is what? Clumping, right. Okay. So they've got rapid multitest, and you're going to learn the latex agglutination test for protein A, and this comes back with protein A. It's positive. Okay. Now, right now, these might be foreign to you. That's okay. In 6 weeks, they're not going to be. So that's why I'm saying you might want to change your cards as you go along, as you learn more things. Okay. But this is a good starting point. Okay. Prevention and treatment. Okay. Hand washing, cleansing the wounds, disposal of everything, universal precautions, isolation of patients that have open wounds. Okay. And then ban the nasal staph carriers. Okay. And nurseries but like I said, we're all humans. There are people that are carrying, they don't know. Okay. Treatment. It's a toxemia treatment, so it's going to be intensive therapy, and it takes a long time to get over this infection. Oftentimes you've got what's called MDR. Get used to that abbreviation, multi-drug resistance. And oftentimes they do a culture insensitivity test, which is looking at antibiotics that it might be sensitive to. Okay? So, all right. Complications. If you have SSS, you can easily go to toxic shock syndrome. What's the signs and symptoms of toxic shock? Nausea, fever, vomiting, rash, organ damage, and failure. Abscesses, and we don't want to see meningitis, but it does happen. Okay, what does sequelae mean? These are complications from the infection that you see sometimes within weeks, sometimes within months. Okay, with Staphylococcus aureus, the heart seems to be a nice target. Okay, it targets the valves oftentimes. Okay, can cause endocarditis. What is endocarditis?
Inflammation of the endocardia.
Yep, the endocardia gets inflamed. Okay, this is not a chronic infection. This doesn't have any latency. Okay, and then put anything else that will help you remember things. Okay, here you have predisposing conditions. Most of the time you're going to see it in infants. Okay, sometimes you've got multi-drug resistance that you've got to worry about. So neonates and infants, kids under 4, and this is a very tough organism. It will survive outside the host very well. And it's tough to treat because we've got MDR. What does MDR stand for? Multi-drug resistance. Okay? Now, take a look at your card, okay, that you did. Do you have all of these things on there? Yeah? Good? Most of them were in that handout. Okay? And some of you are going to go back and augment the cards. Okay? Now, if we go to the list on this, okay, use highlighters. You might want to use highlighters for their signs and symptoms on all the cards, okay? Is that what you did? Yeah, cool. All right, so you don't want to be putting too much information. You're going to have to kind of gauge, especially after the first quiz, how much information is too much, how much is not enough, and so forth, okay? Do you feel a little better about them now? Okay, sort of. All right, what are you going to be doing this weekend? Cards, because you have to make them and then you have to study them, right? So don't wait until Wednesday night thinking, oh, I'm going to do my cards now. Okay, over the weekend, Okay, get with your study buddies that you're doing your cards with and make sure that you are practicing, okay? Any question about cards? Does this help? Okay, all right, cool. Good, okay. All right. Okay. I can't recall. Did we get to this last time? Okay. Did we get through all the definitions? All right. Let's do some definitions and get through some of this. Yeah. Okay. Take the... All right. Are you dreaming about this yet? Good. That's a good sign. Because if you're dreaming about it, that means it's getting into your long-term memory. That's good. That's really good. Are you grossed out by everything now? Okay. So let's start with here. Let's make sure we got all our definitions. What is a pathogen? Any disease-causing agent. What is contamination? Okay, pathogenic microbes on the surface of a host. Infection is invasion of the host by pathogen. Etiology. Causative agent of the disease. Good. Etiological agent. The scientific name of the causal agent. I've got a blank there. I don't know. I couldn't get it off. I don't know why. I'm just thinking about it. So. Okay, good. Let's talk about disease. Is a change in state of health. Okay, we talked about signs and symptoms. Okay, signs are changes in the body function that are seen by the practitioner. The symptoms are changes in body function observed by the patient. Okay, complications. Serious disease effects seen only in a small number. Yeah, usually in a small number. And when you see complications, who are your usual suspects? The young, very old, immune compromised. Okay? And sequelae, permanent or semi-permanent changes to health seen long after the pathogen is gone from the body. Okay? We see this with pertussis. Okay, you have your initial pertussis infection. Okay, it goes on for a while. Hopefully, you never get it because your immune system reacted to the vaccine. But oftentimes, if you have a patient that's had pertussis, about 4 to 6 weeks later, they can develop pneumonia. Why? Because pertussis makes a toxin. The toxin destroys the cilia in the upper respiratory tract. So your patient can be susceptible to pneumonia. Who's going to be the folks we look for? The young, the old, and the immune compromised. Yeah, okay. All right. I like tables. They're easy to see. Over here are the signs, and here are the symptoms. Okay, so a sign might be fever, but your patient says, "Oh, I've got chills." Okay, yeah. So so you can kind of see some of these things. All right. Am I gonna on an exam expect you to regurgitate this? No. Okay, I'm not that evil. I've had professors that evil. I'm not going to be one of those. But this is here so you can, have some familiarity, okay? All right. Let's talk about some terms here for normal flora and microbiota, because that's what we're going to start with, because 95% of your microbiota is very helpful. Okay, what is a symbiosis? This is Bio 1. What is symbiosis? Yeah, it's a relationship between two organisms. For micro, oftentimes we talk about the host and the pathogen. Okay, and there's lots of different flavors or symbioses. That's the different colors. The first one is a mutualism. When you have a mutualism, tell me about the host and the pathogen. The pathogen definitely benefits. That's a plus. Does the host benefit? Yeah! Give me an example of a mutualistic relationship with your microbes. What? I can't hear you. Gut bacteria, because what do they do for you?
Take down food and all that stuff.
Yeah, they help with your digestion, and they make 2 important vitamins. What vitamins do they make? They make 2. One is vitamin K, and the other one are some of the B vitamins that can be made by your gut bacteria. That's a very good mutualism, right? Okay, tell me about commensalism.
Neither benefits or harms.
Okay, one thing benefits, and there's no effect on the other one. Okay, so the microbe will benefit, but there's no effect on the host. Give me an example of that one. Okay, I'll give you one. Okay. All right. This is going to make you itchy all day. All right.
Is it the skin mites? Is that what we're doing? I knew it. I knew it.
Yeah, yeah. Okay, here we go. Okay, I hope we have sound. Okay, here we go. Oh, now we get some advertisements. All right. I can't get out of these, so we're just going to have to live through them. Great. Ooh, the bug. Okay.
You have few friends.
Oh, now we get Masterpiece Theater. All right.
You don't know how to deal with him.
So intense.
Well, you're on a course since the
Talk about microbes. I would not want to be living in there.
And the action you had.
They don't even have soap. Yeah. 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 Look at that. Oh my goodness. How gross. Okay. Now we're going to be freaked out.
Hey, you got something on your face. Well, more like living in your face. Can't see them? Here, we'll show you. Researchers just use a little glue. Don't try this at home. When that thin layer of skin comes off, it takes some tiny hair follicles, that barely visible peach fuzz, with it. Those follicles that came out look like a miniature forest. And inside some of them, that's a face mite.
Dermadex. Yeah.
Entomologist Michelle Troutwine at the California Academy of Sciences in San Francisco studies these long-term tenants of ours. They've got 8 little legs because they're actually arachnids related to ticks and spiders.
I'm more afraid of that one.
Yep, you almost certainly have dozens of these stowaways on you right now and don't even know it.
You're never alone.
Usually, your immune system keeps them in check, but in rare cases, a population boom causes a red rash. But don't freak out, seriously. They're actually not such bad house guests. You're not born with them. Face mites are passed down from parent to baby. They spend their days tucked right inside our hair follicles, next to the hair. All cozy. See that yellow stuff? It's sebum, that greasy oil your skin makes to protect itself from drying out. That's what face mites eat. When you're asleep, they climb out to the surface and mate before crawling back into your pores to lay their eggs.
Right on.
So that's fun.
Well, you had sex. You're gonna have it.
But if you're thinking about scrubbing them all off, forget it. You'll never get rid of all of them. And here's the weirdest part of all. Face mites don't have an anus. They just eat and eat, but never poop.
Until they blow up, right?
They've made our vast landscape of skin into their own personal kingdom. Just think of them as a natural, maybe even healthy part of your skin ecosystem. Now that you know that, you never have to be lonely again.
That's right. You're never alone. Okay. Yeah. That's lice. That's not them. Okay. Ooh, what's that? A leech. Yeah. That's a tick. They should show a bed bug. Yeah. So anyway. So yeah. Wow. That's a commensalism that you could have gone your whole life without knowing about, right? Okay. Everybody's like, ah! All right, for parasitism, the host does not do well, the parasite does well. So one positive, one negative, okay? All right, opportunist. Okay, you have a lot of, as you'll see in chapter 13, you have a lot of microbes that are there. Do you have the microbes that cause strep throat right now? Yes, you all do. Do you have the microbes that cause C. diff in your gut right now? Yes, you always do. But when the normal microbiota gets disrupted, antibiotics, illness, colonoscopy, okay, can the C. diff come? Yeah, that's an opportunist. Strep can be an opportunist. If you have a patient that's really old, young, or immune suppressed, sometimes they get opportunistic infections, okay? You don't usually see them, all right? Microbial antagonist. What is an antagonist? Okay, does it stop or enhance? Antagonize. When you antagonize someone, that's a negative thing, right? You shut it down, okay? So a microbial antagonist is something that will shut down other things that go on, and we'll see this as the semester goes on about a microbial antagonist. Okay, let's talk about your benefits of your relationships. Are you better off with them or without them? Think about that statement for a moment. You can apply that to everything in your life, right? And personally, I think physics and particle physics quantum mechanics is easier than relationships. So, all right, are you better with them or without them? It's always a great question to ask. So let's apply it to the resident microbiota. So it stimulates what? The immune system, okay? You've got defense that create an environment unfavorable to the pathogens. Okay, like acids, like metabolic products. I mean, the sebum that you saw that the dermics live in actually is a little acidic, and so that helps keep some of the pathogens under control. Prevent overgrowth by opportunists in the gut, vagina, and skin. It's required for normal intestinal, immunological, and CNS development. And it produces essential micronutrients. What are the two vitamins it produces? K and some of the B's. Okay. Now, here's the adverse effects of your resident microbiota. You have the potential for endogenous infection. Okay, what does endogenous mean? It comes from you. Okay, if something is endo, what does endo mean? Inside. Yes, good. Okay, and then it can be reservoirs of, reservoirs, and you get human carriers of pathogens. So your normal resident microbiota, you could have bad players in there that you can carry human pathogens, okay? So when it's all said and done, you know, there are actually much more benefits until you become what? Old, young, immunosuppressed. okay? All right. This little diagram shows you where you find some of your normal microbiota, okay? How many cells do you have with you right now? 10 to the what? 10 to the 14 human cells. Or, yeah, 10 to the 13. 10 to the 14, yeah, so body cells are 10 to the 13th. You have 10 to the 14th bacteria. Who's running the show?
Bacteria.
Yeah, bacteria. Okay. We've got hosts and symbionts. Okay, so we've got normal microbiota that we find in the nose and the nasal pharynx. Okay, but sometimes they invade. And they'll invade like the meninges of the brain. You've heard about the golden triangle, right? The golden triangle, that you don't mess with anything in this area. Why? Because it's so close to the brain. Okay, so you walk this line of what is the beneficial outcomes, what could be the adverse effects. Okay, now your internal organs, tissues, and fluids are microbe free. Okay, so where are you going to find resident microbiota? Anything that's exposed to the outside, and this includes your gut, because remember, your gut is just a big tube, right? Okay, so you have transients that microbes can occupy the body for a short period of time, and then you have residents that are really well established. Okay, so got a list here of where you get normal microbiota. Okay, and if you notice, it's everything that touches outside. Okay, you don't have it in the lower respiratory tract. Why? Because you've got systems to prevent that from happening. Okay, yeah. So yeah, we talked about endogenous infections. We talked about all that. Okay, fluids within blood, urine. Okay, so urine, should it have bacteria in it? No, in the kidneys it's sterile, okay? In the bladder it's sterile. When do you get bacteria? As it leaves, right? And a UTI is when bacteria has gone up, okay. All right. Yeah, so you get an idea of what's sterile. Okay, the uterus and its contents are normally sterile until birth. As soon as you break the fetal membranes, you expose the infant. Okay, so essentially, until it goes through the birth canal, the baby's pretty much sterile. Okay, so where does it get its bacteria from? Okay, where does a baby get its bacteria from? Mom, putting things in its mouth. Okay, all right. Now, the mom's skin, especially if they're nursing and receiving breast milk, you can get some really good colonization. Okay, you can see. Yeah. Okay. Again, put another table here. It shows you some common microbes that infect the skin, common ones that do the GI tract, respiratory, genital tract, urinary tract, eye, and ear. Again, I'm not going to expect you to regurgitate the tables, but you should use these for references, okay? Okay, so we've talked about beneficial microbiota. If you notice, a lot of them are lactobacillus. Where in your food do you get lactobacillus? What kind? It has to be special. Not all dairy carries lactobacillus. Yogurts and kefir, they tend to have lactobacillus, okay? All right. Now, we do know that if you don't have a microbiome, and we see this with germ-free mice that are raised in sterile environments, you have abnormal stress, anxiety, sociability, and cognition problems. Okay, let's think about that for a moment. If they're sterile, that means they have no bacteria in their gut. Are they getting required nutrients? No. Where is most of serotonin made? Where is most of your serotonin made? In your gut. Okay? Do we understand the impact of microbiome on serotonin production yet completely? No. I wish I was in your shoes and waiting, because in the next 20 years, if I could predict of my crystal ball, I would say that screening your microbiota in your gut is going to become a routine thing. Okay? Why? Because we can have a lot of changes. You know, they say, oh, a better diet and then you have a better immune system. I'll give you an example. Oftentimes, this doesn't happen with every patient, but a lot of patients that avoid C. diff, okay, they've taken lots of antibiotics, they avoid C. diff, look at their diet. If they've avoided it, their diet is usually high in fruits and vegetables and in things like oatmeal. Why? Because that provides complex carbohydrates for them to, the normal microbiota, to make the acids that are necessary to keep C. diff under control. Okay? When you see C. diff, you know, people that are on lots of antibiotics and they've got a crappy diet too, and they're eating ultra processed and they're not getting normal microbiomes from their food, okay, then they're more at risk for C. diff, because that resident microbiota needs those things. You know, you wash your fruits and vegetables. I know on like social media they show you ways to, you know, just about sterilize your fruits and vegetables. I think that's really harmful. Okay, you do need some bacteria. I mean, it's okay. The amount of pesticide is like, you know, one hair versus your whole head of hair. Well, I'm not saying that for anybody who's bald or anything, you know, but like, it's just like one. It's so negligible. Okay, unless you're eating strawberries, and strawberries you can wash really well. Okay, but when you're, you know, trying to get every little microbe off your food, that's not necessarily good. Okay, let's look at what they do for a lot of chemo patients. A lot of chemo patients, what do they say? No fresh fruits and vegetables until you're done. Why? Because they've got so many microbes on it. You've got to have everything cooked. Okay, so I mean, think about it. We've evolved with all of these things, these things to eat. I mean, look at, in the old times, did they wash their fruits and vegetables? No, they did. They washed themselves. So why would they do that? Okay, so yeah, so keep in mind about these beneficial microbiota. So when we talk about your gut, your GI tract is 25 to 35 feet long, and it's anaerobic. Okay, so what are you going to see? You're going to see anaerobes there, like lactobacillus and clostridium and all of these anaerobic microorganisms. So again, another little table that kind of shows you all the different microbes that will live in your gut that are, you know, anaerobes. Okay. I put this slide in here because it shows in yellow the areas that have microbiota. Okay. So you can kind of see the areas that will have microbiota in the genitourinary tract, in males and females. Okay, let's talk about the vaginal tract for a moment. Okay, vaginal tract has a normal microflora, microbiota. One of the species that's really beneficial is Lactobacilli, and it helps maintain this acidic pH, and it's anaerobic. Okay, but beware of the opportunists. Okay, what's the opportunist that likes to infect this region? E. coli. Where's the only place you're going to find E. coli? In poop. Okay, so where does it go? It goes from the gut to the vagina and then to the urinary tract. And that's why you see most UTIs are gram-negative E. coli that migrated. Now, why is this so important for female? It's the anatomy, right? I mean, look here. Everything. Well, no, look here. Okay. Okay. Everything's so close together. Everything's so close together. Dudes, not so much. Okay. Now, if you see a UTI in a male, let me just tell you clinically what you see. Unless they're elderly, what do you test for? STIs. Yeah, STIs. Because you have your normal microbiota, and if you start to see a UTI in elderly, if the prostate isn't functioning and the bladder isn't emptying, you can see that. You can get people that get really dehydrated. Okay, that's fine. But if you see a UTI in a young person, you're gonna screen for STIs as well. Okay. All right. Here's another chart, shows all the lovely bacteria in the vaginal tract. Okay, where did your flora come from in utero? Your microbe what? Your microbe free. Okay, and it's mainly lactobacillus. Okay, that's in the vaginal tract. Okay, and these actually produce hydrogen peroxide, so they'll be positive in a prostate test. Okay, there are differences in the biota. If you have a vaginal birth versus a C-section, if you're breastfed versus bottle. Okay, why? Because of that, the vagina, and while you're feeding on the breast, you're going to get microbes to help populate you. Okay. Yeah, so then as they start moving around, they get more flora, microflora from the environment, and eventually the flora becomes more stable. Okay? Yeah. One of the universities that have done a lot of work on E. coli and contamination and how you colonize and things like that is Emory University. Where's Emory? Do you know where that is? It's in Atlanta. It has a lot of, it's next to the Centers for Disease Control and Prevention, so they do a lot of work. I'll tell you, this story actually really did happen. When I was a graduate student, we had a genetics and microbiology retreat up at Lake Arrowhead at the UCLA Center, and we invited a lot of people that do environmental microbiology and things like that. So our guest speaker did a very interesting study. Him and his team at Emory sampled diapers from age 0 to age 1 year to see the development of microbiota. Okay? In 90% of their, and this was, years ago, so I know it's more than that now. But in 90% of the samples by 7 months, those infants had drug-resistant E. coli in their system. Drug-resistant, okay? One of the things we're going to learn about microbes is they're extremely promiscuous. They will change genes with all sorts of things. They have viruses to help them, okay? And so when you talk about multi-drug resistance, it moves very quickly. Can you imagine a little 6 and 7 month old that's got already drug-resistant E. coli in their gut? What does that tell you? Where did they get it from? Probably their mom and their environment. Okay? So that tells you there's a ton of drug-resistant E. coli around. Okay? That's really bad for folks that have UTIs. So they have a new classification for some of the new UTIs called ESBL. Have you heard of that? Okay, ESBL, you can look that one up. That's a new super bug that are causing UTIs now. Okay, very ironic. While we were there, we were all poisoned. So we went to this lovely conference and it was intense. It was really great, a lot of good information. We're driving back from Arrowhead and people are pulling over to the side of the road and throwing up, and I'm thinking, you drink too much, until it was me, because I don't drink, and it's like, oh no. And later that night across the street at Riverside Community, there we all are, throwing up our guts, the runs like crazy. There was a viral contamination. I think this was back before they had identified norovirus, but there was a viral contamination in the food and everybody got sick. So our poor guest speaker from Emory had a 5-hour flight back to Atlanta and got sick on that. So here, come and teach us stuff, and then we'll poison you. Yes. Crazy. Yeah. All right. Koch's postulates. We've done Koch's postulates. We spent time. Okay, I'm not going to spend time filling this in. This is something you should be able to do from memory. Okay, and just keep in mind, we can use Koch's postulates for some infections, but not all. The ones in red here, we can do. Okay. All right. So 1,400 pathogen species. Okay, less than 1% of all microbes, and you can't use Koch's postulates. Why? It's not always practical and it's not always ethical. So we can't use it for absolutely everything. Okay, let's start talking about some patterns of diseases. Before we go on, any questions about the stuff that we've talked about? Okay. Okay, let's talk about patterns of disease. Sporadic disease. What belongs in this blank? Randomly, okay? If it's endemic, it's always present in the population at low levels. And you can see on this chart of the US, this would be something that would be endemic. An example of an endemic disease, cold viruses like adenoviruses are always here. Hantavirus is endemic in the Southwest, okay? Epidemic. What is an epidemic? When you have a suddenly higher than normal incidence, okay? All right, have we got epidemics right now? Okay, what's an epidemic we've got right now in the U.S.? We got measles. We got a lot of measles, okay? Influenza A, influenza B, okay? Sporadic. Okay, we saw this is it for sporadic. You see a few cases. What is a pandemic? It's worldwide. Okay, so you lived through one of the biggest pandemics since 1918. Okay? Yeah, I hope we don't have to do it. Pandemics usually come once every 100 years like that. So we were overdue, but that doesn't mean I want one. Okay? All right. So, just to give you an idea, today, this is so exciting. Okay, I've gotten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 emails so far today. I'm hooked up with the global infectious disease surveillance system. Why is this? Because of my job with the Army, but it also comes in handy with microbiology, because I can see what's going on in the world. And one of the things that has me concerned right now is going on in the Congo. What's going on in the Congo? Have you heard?
The children.
The children, yeah. What did they do?
They ate a bat.
They ate a bat. Okay? Rule number 1 of life, don't eat bats. Okay? And what happened to them?
They died.
They all died. With
3
or 4 hours, they were dead.
What was this?
Yeah? The Democratic Republic of the Congo. But yeah, so I look for these because why? What category does that fall into out of these 4? Sporadic, right. Now, what could happen is if we see, they died within 3 and 4 hours, but I'm concerned about who took care of their bodies, right? Okay, with Ebola, it's always, if you read the cases of Ebola, it's the patient that died, but it also then who cared for their bodies, and then they get it. And then they have a funeral, and all those people get it. So that's what we look for when we're looking in terms of public health. So yeah. Okay, so patterns of disease. Here is the disease cycle. Survival outside the host, which is what? This is reservoirs, host reservoirs. Okay, transmission to the host, portal of entry. And you notice there's a big line there. Okay, because once it enters, it goes through this process, which is attachment to the target tissue. And we're going to talk about different ways it attaches to the target tissue. colonization, damage to the host, and then a portal of exit. Okay? So this disease cycle, you gotta know. Okay? And now we're gonna add some details. Okay. There's two types of infections, or sources of infectious disease. There's endogenous infections. Endo means what? Inside. Endogenous infections caused by the patient's own pathogens or opportunists among their microbiota. Exogenous infection, what is that caused by? That is organisms that enter the patient from the environment. Soil, food, water, people, and what is this F word? My favorite F word. Fomite. Yeah. I'm glad nobody said something else. Okay. Yeah, fomite. What is a fomite?
Inanimate object.
A non-living object that can carry microbes. What's probably the most dangerous fomite that everybody's going to touch today?
Their phone.
Their phones. Yeah, and the door handle, right? Okay. Okay, let's talk about human reservoirs. Symptomatic carriers and asymptomatic carriers. Gosh, this is what made COVID such a terrible thing. Okay? Because 60% of COVID patients were asymptomatic. It made contact tracing a nightmare. Okay? Who could be human carriers? Or what do you carry? Diphtheria, hepatitis, typhoid, amoebic dysentery, polio, streptococcal infections, and pneumonia. Okay? Streptococcal infections and pneumonia. Okay. All right. Well, how are we doing on time? Not too much left. Okay. So, I'm going to stop right here, but I want you to see something about asymptomatic carriers. Okay? Give me a minute here. Okay? Don't put your notes away. You may want to take notes on this.
This kind of stuff in this season, we're under tremendous threat. There's nature and mankind. If you get you, won't get you.
Okay, they didn't wash your hands either. Okay.
Hello, I'm Jackie Johnson, and today we will be discussing Typhoid Mary.
Have you seen this?
Let's travel back to 1900, New York City. Immigrants were just flooding in from all over the world to start their new life in America. And then we see one angel face. And she says, I'm Mary Mallon, I am Irish, I'm proud, and I'm here to cook, baby. So, Mary's signature dish was vanilla ice cream with sliced peaches. The rich people would call up their friends and say, honey, have you had Mary Mallon's peach vanilla ice cream? It is the best friggin' dessert that I have had. And that's how she got around, word of mouth, old school marketing. So, what is it, Oyster Bay? Oyster Bay is like the Beverly Hills of the time. Teddy Roosevelt's there, that's where he summers. Charles Warren is there. He is the banker to all the rich people, including the Vanderbilts. So what happens to his family? They, all of a sudden, get sick. And they say, we're rich. We don't have to deal with disease. Dr. George Soper rolls up. His job is whatever a sanitation engineer is. Dr. Soper says, well, honey, I'll be honest. Everybody in your family has typhoid fever. Charles says, what? What does that mean? Typhoid? And Dr. Soper says, you could hemorrhage from the inside. People die from this. This is 1900. We don't have pills. We don't have, what's it called? What's that pill that solves everything? Antibiotics. We didn't have that, okay? There's no antibiotics, okay? So Charles Warren says, here's a bunch of money, hunt down the source and kill it off. Dr. Soper gets to business. He goes through the plumbing. He interviews the local fishmonger. He's trying to find the typhoid and finding dead ends everywhere he goes. But then all of a sudden he gets a call from Manhattan. There's a wealthy family who just came down with typhoid. The little girl is very sick. She has her covers up to her face. She says, Daddy, I'm cold. I'm very cold, Daddy. So Soper rolls up and interviews the family. He realizes they just had a new chef. He says, wait a minute, who was the chef? They said, well, she was a delightful Irish immigrant named Mary Mallon. And Soper says, wait a damn minute! That's the same woman who was cooking for the family at Oyster Bay! And he says, I think we're onto something, baby. I think I'm onto something. So anyway, Soper rolls up to Mary's house. He says, excuse me, ma'am. I'm pretty sure you have typhoid fever, and I'm pretty sure you're giving it to everybody that you're cooking for. And she says, excuse me? I am an Irish immigrant woman trying to make it in 1900 New York. How dare you accuse me of being unsanitary? Then she chases him out with a fork and says, if you ever come back, if you ever try to f with my money again, I will take you out. So he needs to get more evidence. He sits down at his desk. There are papers everywhere. And he says, oh my God, 8 families Mary Mallon has cooked for? 7 of them have contracted typhoid? That's not a coincidence. That's not. That is fact, honey. Spit everywhere. It happens. You know what else happens? Shit.
Great.
Yes,
You
yes.
remember where you are?
Let's see, because, you know, the brain's fading, I'll be honest. The brain is going out.
I love that you're always honest.
Okay, so we are pissed at this point. The health inspector and Dr. Soper roll up to Mary's. They bust over the door, and they said, Mary, we have unequivocal proof that you're spreading typhoid all over this